Okay, I thought it might be good to talk a little bit about Lab 2. That's coming up on Friday, so you're starting to think about it. Hopefully, you've had good experiences in your lab sections with the TA. But just in case there's a couple rough edges, I thought we could talk about them a little bit now. So, if you take a look at the Lab 2, you're supposed to go ahead and show the TA you've completed the lab, and they'll record your score. If you take a look at it, they want you to talk about creating some different types um, and pointers to things and arrays. And then they want you to read in some numbers using scanf. And then they want you to actually write this, convert this bubble sort pseudocode into real code. So let's just get you started on a few of these items. Hopefully, help you get past any hiccups that you might see. So I'm just going to go ahead and go to, here's a window that I have open to Schizo, and of course I'm in a machine called Death Valley, which is one of those machines. And I'm going to start by editing a file called goo.c. I think he suggests you use Nano to edit them, but I am really slow. So I would suggest if you're going to develop on these Schizo machines, I would suggest you look at using Vim instead. And this openvim.com tutorial is a really good way to get started. It will tell you how to do everything. I'm going to give you a little bit of a tutorial because I think you can actually, with a few commands, get enough to actually edit your programs here. So I just thought we'd jump in and do a couple of those. And so here I am. You can use VI or Vim. It's the same program, and you can type the name of the file you want to create, and then you notice it will bring you to this point. It has a bunch of these tildes and then the name of the file, as well as what line number you are on and which character in the line. Okay, now Vim is actually a line-oriented editor, which means that it's going to, right now it's sitting there waiting for a command. It's in command mode. And then when you get into a different mode, like insert mode, then it will let you type actual characters. So I'm just going to type the character I, and you'll notice down here that it says insert mode. And now I can start typing stuff. So maybe I'm going to say, I want main here, and I want to have some curly braces. And you're going to have to move around with the arrow keys, or you can keep your fingers on the home keys, and you can actually use J. You can use, by the way, and then you hit escape to get out of insert mode. You can hit J to go down, K to go up, L to go right, and H to go left. So that's one of the advantages of Vim or other line-oriented editors, is you can keep your fingers on the home keys. Okay, so as soon as you have to go grab your mouse, it's going to really slow you down. So I'd encourage you again to go to that Vim tutorial, figure out how to do things. While we're here though, let me just say we're now back in command mode, so I can type all kinds of characters and nothing will happen till I type an I to get into insert mode, or I can do O, which will open a line below me, and you'll become familiar with a lot of the other commands in here. You can actually hit colon help, which will give you help on Vim and everything that you'd ever want to know about it. Here's how to use the cursor keys, etc. Okay, and when you're done, you can say colon WQ, which means write the file out and quit. And so WQ, and it will write it out, and now there'll be a file called goo.c inside of this directory. Okay, so that's all I'm going to give you right now. Go ahead and play around with it, and I'll give you some more commands as we kind of get going here. So if I want to add something in the body of this main function, again, main is the function that's called when your program first begins to run. Maybe I will want to say, let's create an array of characters. So characters are 1 byte long, and foo is my favorite name. And if we wanted to make an array, we can say, well, it's an array, and it's equal to an A, and a B, and a C, and a D. Okay? And now we've got an array with 4 characters in it. And I can, if I wanted to, I could then print one of them out. Print F, and I could say something like is %C, and that will print this out of the character. Back N terminates the line. And then I can say pass it foo sub 2. Okay, so this is basically the way printf works. Is we're going to pass it the format string followed by a list of other values. And if I were to do this, I hit escape to get out of insert mode, :WQ to write it out. I can say gcc goo.c, and it will say, you are using printf, but you haven't included standard IO. So of course that's what I want to do. Why doesn't it just do it for me? I don't know. But anyway, we're going to go ahead and put that in there then. And now when we do it, by the way, if you haven't learned, exclamation mark says, go find the last command that I did that had BI in it. I'm now going to say, give me the last command that had G in it. So that kind of saves you a few keystrokes. Now when I get it to compile, as you notice, if I don't say anything, it will put it in a file called a.out. I can run it by saying ./a.out, or I can say gcc -o goo.c, and that says the -o says send the output to now a program called goo. And when I do that, then it's going to go ahead and create this executable called goo, and I can say ./goo and run it too. Okay, so just a little bit mechanics here. And now let's go ahead and talk a little bit about pointers, because that was another thing that they wanted you to become familiar with. So if I wanted to, I could create a character pointer, and I could assign it to the address of foo sub 1. Okay, so let's see. What do you think that's going to do? So that will say, here's foo 0, here's foo 1. So that pointer now points to the address of that B. So I should be able to then say something like printf, something like foo sub 1, it's just, I'm going to print that out, is equal to %C, and then it should print out the character that pointer is pointing to. So I can dereference the pointer by saying contents of C pointer. Okay? And so that will then allow me to print that out. And again, when I compile it, again, up arrow will get you to previous commands. And I can then run it. And I'll see that, yes, well, indeed, that when I printed out the contents of the pointer, it was indeed the B that I expected it to be, or foo sub 1. Okay? You'll notice that I could also change that the contents of that thing. In this particular case, I could say something like foo sub 1 is equal to a z, and then when I printed it out, it's going to have a different value. So here we go. Compile it, and it's a z now. Okay, so let's talk about different types. Okay, here we've got a character pointer. We could also create a integer pointer. This is going to be really confusing. And what would happen if I said iPointer is equal to the address of foo sub 0? Okay, that will allow me, I'm pointing a integer pointer at the address of a character. Wow, what do you think is going to happen if I try to print this out? And so we can try that by saying, by the way, so what I'm doing here, YY yanks a particular line, so I just hit YY here. Then I went down and I did a little p, and that puts the thing you have yanked into your buffer from Vim. So here I am. I'm going to now print out what the iPointer is pointing at, the contents of it, and see what is in there. And so it turns out that he's going to say, what? You can't do that. You can't assign an integer pointer to the address of a character. However, one thing that you can find with C is you can just tell it to ignore anything bad that you're doing, and you can typecast it. So here I can say int pointer. I can typecast it and say pretend this thing is a int instead of a character, and let's see what happens. So now we go ahead and run this, and we will find that sorry, what I was doing here. This should be, let's print it out as a integer here. %d does integers, and it will tell me that I've got a weird number here. So it's now interpreting that array of characters as an integer. And in fact, if I wanted to, I could print it out not as a integer value, but I could print it out as hex and take a look at it. And so now, if I take a look at this, you'll notice, oh, this is really kind of strange. We've got a 64, we've got a 63, we've got a 7A and a 61. So if we want to, we could actually look at a, we could go to and look up ASCII, and it turns out that ASCII is the way we represent characters on a computer. And so you'll notice that the thing I saw, if I look at this hex column, if I look for what a is, it's going to be a 61 hex. A Z is going to be a 7A hex. And so if I take a look at what I was actually seeing there, here are those characters. Remember what did I have in there? I had an A, and then I put a Z in the next one, and then a C and a D. So if I take a look at this, the A that I saw was a 61 hex, and that's what I actually saw as the first character here when I actually ran this program. There's the 61. Notice a difference in byte order too here. Here's the A, there's the Z, there's the C, and there's the D. Okay, so you can point any kind of a pointer at memory and it will try to do the best it can with it. Notice that I could also, let's try some other bad things I could try here. I could actually try writing to this array of ints using this array of characters using a int pointer. So I could say I pointer, the contents of that is equal to 5, okay? And what it's going to say is, now let's go ahead and print it out, and then let's try printing it out as a character, and you'll notice that all of a sudden we have, it is a 5 when we print it out, but it's no longer anything that makes sense to the character array. So be careful. A pointer is kind of like a loaded gun that you can point at anything, and if you point it at your foot, you're going to shoot yourself in the foot. So be careful. A lot of errors in C come from not understanding pointers and how they work. If you guys have more questions, let me know. But that's basically what you need to do for this lab. And then once you've, we'd also wanted to use scanf. I'm sorry, don't want to make this so long. But if we take a look at this, we might want to do a scanf. It's also going to use pointers a lot. So I can actually say, let's do a scanf, and I can put this into a int input, call it. I can do a scanf and say I want to get something from the keyboard that is a integer, and I'm going to then pass it a pointer or the address of input. And what it's going to do is take whatever you typed on the keyboard, and it's going to put it into this whatever's at this address. So then I can print out what that integer is, and let's see what happens. So now when I compile it and run it, you'll notice it's going to hang here waiting for me to type something in. So if I type in 45, hit the enter, then it's going to print out, oh, I got a 45 from the keyboard. So you're being asked to go ahead, input some values so that you can bubble sort them, and then this will allow you to actually have a list of numbers and take them from unsorted order and put them into sorted order. Give me a holler if you think you have problems with that, and we can talk about that later, but that's basically all I wanted to show you guys. Again, just become familiar with how pointers and arrays work and different values that we could put into them.